Good day. Last week we have talked about the SSS, ASA, and SAS congruence postulates, and we have already practiced or learned how to apply those postulates in proving triangle congruence. Now this time, let's talk about the isosceles triangle theorem. So to recall, we know that isosceles triangles are triangles that have two equal sides, right? Now let's proceed. Now, the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite them are also congruent. So that is, if I have here triangle ABC and side AB is congruent to side AC, then angle B is congruent to angle C. Okay? Now, since our statement above is a theorem, now we need to prove that theorem. So here our given is triangle ABC with side AB is congruent to side AC as shown in our figure. Now let's prove angle B to be congruent to angle C. Okay, so again, we are given here triangle ABC. This is an isosceles triangle because two sides of our triangles are equal. So let's now try to prove that this angle is congruent to this angle. Okay? Let's start with our proof. So as I always keep on saying, when you do proving, you always start with the given. So our given here is triangle, is side AB is congruent to side AC. So that is this side is congruent to this side. So that will be side AB is congruent to side AC. And our reason for that, of course, is given. Okay? Now, we need to draw an auxiliary line to form two triangles because in our figure here, we only have one triangle, triangle ABC. So to help us prove the congruence of angle B and angle C, let's try to divide this triangle into two triangles by drawing an angle bisector of A that intersects BC at one point. So let's have this angle bisector of A as segment AD. So let's draw it. Okay, so we have this segment bisector, no, not segment bisector, angle bisector AD. So let's write in our statement, what did we do? We draw segment AD as an angle bisector of angle A intersecting segment BC at D. Okay, and our reason for that is that every angle has exactly one bisector. Okay? Now, remember that in our second statement, we said we have drawn segment AD as an angle bisector of A. So meaning to say, segment AD divides angle A into two equal parts. So segment AD divides angle A. So we have already formed two angles now. That is angle, let's name this one as angle 1 and angle 2. Since segment AD is an angle bisector of A, then meaning to say segment AD divides angle A into two equal parts. So angle 1 is congruent to angle 2. And that will be our third statement. And our reason for that will be definition of an angle bisector. Okay? Now, look at our figure now. So we have already formed two triangles, right? We have triangle AD or ABD and triangle ACD. So looking at the two formed triangles here, is there a common side? Okay, there is a common side, and that side is side AD. Okay, so that will be our next statement. Let's say segment AD is congruent to segment AD, or segment AD is congruent to itself. So, recalling our previous discussion on the SSS congruence postulate, so we have established there, or we have shown in our two examples, reflexive property of common sides of two triangles. So same here also. So since segment AD is a common side, then we'll say segment AD is congruent to segment AD. And our definition for that is the reflexive property. Okay? Next. So, looking at our statements here, going back to statement 1, we have already here established congruence of one pair of sides in our two formed triangles. So let's just write a small note here over here indicating that we have already proven one pair of side to be equal. So we have one side here. And in statement 3, we have also established the congruence of a pair of angle, which is angle 1 and angle 2. So we have angle. In statement 4, we have established congruence of another pair of sides, which happen to be a common side. So that is one side. So you can already see here that on our figure also, you can see that angle 1 and angle 2 are included angles of our two congruent pairs of sides. So we can already say that triangle ABC, no, triangle ABC, triangle ABD is congruent to triangle ACD. And our reason for this is the SAS congruence postulate. Okay? Now, let's go back to what we are proving in this problem. So in this problem, we are proving angle B to be congruent to angle C, okay? Not the congruence of the two triangles. Okay, let's be clear of that. We will not stop at statement 5 because the congruence of the two triangles is not something that we are asked to prove in this problem. What we are going to prove in this problem is the congruence of angle B and angle C. But we can use our fifth statement to establish the congruence of angle B and angle C. Since triangle ABD and triangle ACD are congruent, then we can say that this angle and this angle is also congruent, right? It makes sense. We say triangle ACB is congruent to triangle ACD. So meaning to say angle B is congruent to angle C. So let's write that. And our reason for that will be the CPCTC. So the corresponding parts of congruent triangles are congruent. So by CPCTC, we have already established that angle B and angle C are congruent. Now let's have the converse of the isosceles triangle theorem. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So this is just the converse of the isosceles triangle theorem. So here, if angle C is congruent to angle B, then angle AC is congruent to angle AB. So let's prove our statement. So we have here given angle C is congruent to angle B. This time, what we are going to prove is the congruence of of side AC and side AB. So the congruence of these sides are what is asked, or is what is asked in this problem. So here, first, let's start with our given. So we have angle C is congruent to angle B. So let's have that one. Angle C is congruent to angle B. And our reason for that is given. Now, next, just like what we did in our previous example, we should also draw an angle bisector of angle A. So let's draw segment AD. Oops. Okay, let's draw an angle bisector of angle A. Okay, let's draw it properly. Okay, so this is segment AD, and that is an angle bisector of angle A. So let's write in our statement, what did we do? So we draw segment AD as an angle bisector of angle A. Okay? And our reason for that, every angle every angle has exactly one bisector. Okay? Next, since we have said in our statement that segment AD is an angle bisector of A, then we know that that angle A is divided into two parts. So this angle is congruent to this angle. Okay? Now, this time, to name this angle, let's use three letters. So we have here angle CAD, angle CAD is congruent to angle BAD. And our reason for that is definition of angle bisector. Okay? Now, let's go to our fourth statement. Look at the figure. Okay? Let's have this one. Now look at the figure. Is there a common side? Okay, yes, there is a common side, and that is side AD. So, just like what we did last time, we'll say segment AD is congruent to segment AD. And our reason for that will be reflexive property. Okay? Now go back to your statements. Check the statements that contains congruence there. So we have statement 1, which is our given. Angle C is congruent to angle B. So there we established congruence of a pair of angles in our two-form triangles. In our statement 3, we also have established congruence of another pair of angles. And lastly, in our statement 4, we have established congruence of a side. Okay, so now I'm sure that you have already realized what postulate we can use to prove congruence of these two-form triangles, right? So in our fifth statement, we'll say triangle ACD, or let's say na lang triangle ADC. Triangle ADC is congruent to triangle ADB. And our reason for that is the side, angle, congruence. So lastly, since we have already established the two formed triangles are congruent, then we can already say that side AC is congruent to side AB. And you're right, our reason for that is the CBC TC. The congruent parts of congruent triangles are congruent. Okay, let's have this one. Refer to the figure on the right to answer the following. If angle 5 is congruent to angle 6, name the two congruent segments. So here, angle 5 is congruent to angle 6. So we know that by the isosceles triangle theorem, we say that SE, segment SE, is congruent to segment SR. So our answer here will be segment SE is congruent to segment SR. Next, if segment TE is congruent to segment TR, name two congruent angles. So here, segment TE is this one. Okay, so if this segment is congruent to segment TR, this one. So let's name two congruent angles. Alright, so by the isosceles triangle theorem, you know that angle 4 is congruent to angle 3. Okay? Next, let's have if angle 1 is congruent to angle 2, okay, determine two congruent segments. Of course, we know that would be segment TW is congruent to segment TO. And number 4, we have if triangle TWO is an isosceles triangle with the base segment WO, the measure of angle 1 is 4x minus 15, and the measure of angle 2 is 2x plus 25. 5. Find the measures of the base angles. Okay. So let's erase our annotations here. Okay. So again, let's understand question number 4. If triangle TWO is an isosceles triangle with base WO, segment WO, and the measure of angle 1 is equal to 4x minus 15, so this angle 1, the measure of that angle is 4x minus 15, and the measure of angle 2 is 2x plus 25. Then let's find the measure of the base angles. Now, what are the base angles of an isosceles triangle? Alright, the base angles of the isosceles triangle are angle 1 and angle 2. So what we are looking for here is the exact measure of angle 1 and angle 2. And since we know that in an isosceles triangle, the base angles are equal, then we can equate angle 1 to angle 2 in solving for the value of x. So our solutions for number 4, we have the measure of angle 1 is equal to the measure of angle 2. So that would be 4x minus 15. That's equal to 2x plus 25. Transpose, we have 4x minus 2x. That's equal to 25 plus 15. 4x minus 2x is 2x. That's equal to 40. X is equal to 20. So that is now the value of x. So in solving for the measure of angle 1, so the measure of angle 1 is equal to, 4x minus 15. Substitute the value of x, which is 20. So we have 4 times 20 minus 15. 4 times 20 is 80 minus 15. So that is 65 degrees. So the measure of angle 1 is equal to 65. And since angle 1 is congruent to angle 2 and the measure of angle 1 is equal to the measure of angle 2, so we can also say that the measure of angle 2 is also 65 degrees. So the measure of the base angles of our isosceles triangle TWO is 65 degrees.